Today, Docker is not optional anymore. It has become an essential, non-negotiable skill. Every company hiring Spring Boot engineers expects you to know it. Let's make sure you do. So in this video, we are going to make sure you actually know how to use it the way company expect. In this tutorial, we'll Dockerize a real Spring Boot application from start to finish. You'll see the complete production-style workflow, not a toy example or a simplified demo. We'll start by Dockerizing an existing Spring Boot project, then create a clean and optimized Dockerfile using a multi-stage build to significantly reduce the final image size. After that, we'll build the image and run the application as a production-ready Docker container. By the end of this video, we'll clearly understand how Spring Boot applications are built, packaged, and run inside Docker in real-world projects. This is not a Docker basics video. I won't explain what Docker is, how it works internally, or how to install it. The focus here is execution. The exact steps you need as Spring Boot developer to ship your app using Docker. But if you want to learn Docker, I am creating a detailed course on Docker for Java developers. If you're interested, you can follow the link in the description to put yourself on the waitlist and enjoy an exclusive discount. Your time is valuable. So I'll skip the theory and focus only on the practical, real-world workflow you actually need. So grab a coffee, relax, and let's get started. Here is a Spring Boot project that we are going to Dockerize. Here, I am going to Dockerize the Spring Boot application that we built in my previous tutorial. Here is the GitHub repository of the Spring Boot project. I will put the link in the description. Here, I have provided a full description of the project. It is well organized, so you should not have any problem following along. Here is the list of API endpoints. This API /product, this endpoint is used to get all the products from the database. And this one is used to get a single product by ID. Here we have many other endpoints. Let's scroll down. Here is the sample object structure that you will get in the response. Okay, let's open a new tab. Here, this is the video tutorial that covers how to make this project. You can check the video link in the description. For now, let's open our IDE and let me show you this project in the IDE. Here, I have opened a project in IntelliJ IDEA. In the left sidebar, you can see the project files and folders. If you look inside this main resources directory, we have our application.properties and here is the configurations for connecting with the database. And it's connected to our database that is running on Localhost. Now, let's check what inside this database. I'm using IntelliJ IDEA's database tool. And here is our product database schema. And inside it, we have this products table. Let's see what inside the table. At this moment, this table contains only one product record. So now let's run the project and check it using Postman. Opening my Postman, and this is the URL to get the list of products from database, and this is the get request. So if we send a request, you can see in the response that we are getting this product data. So our application is running correctly. Now it's time to Dockerize our application. But before Dockerizing, for database connection, I'll do some refactoring. Instead of this URL, I want to use an environment variable. So here I'm wrapping this portion, this localhost along with port with curly braces, and before the curly braces, add a $sign. Then inside curly braces, provide the environment variable. I'll name this db_host. Then provide a colon.
What I'm doing here is if this db host environment variable is not present, then Spring will use localhost as our database URL. Similarly, let's replace this database schema name with an environment variable. Again, wrap it with curly braces, add a $sign before it, and name this variable db_schema and add a colon. Now, similarly for username, replace with an environment variable. I'll name this db_user. If this db_user, this environment variable is absent, then it will fall back to the username root. Similarly, change the password to db_password. Now, run this application again and let's check in the Postman. Here, we are getting the same result. That's because at this moment, I have not set any environment variable, so it's just using localhost, the username and the password. Now, it's time to Dockerize this whole Spring Boot application. Let's open the sidebar. Inside this project, I'll create a new file. Here, I'll create a new Docker file. One thing you need to remember is that this Docker file should be placed at the same folder as the pom.xml. Here, some predefined boilerplate is provided by the IDE. Let's remove that. Now, here, we'll build a multi-stage Docker file. There will be several steps involved. Each step will have its own responsibility. After completing each step, the image created in that step will be discarded. Only the image created in the final stage will be kept. This reduces the overall size of the Docker image to a minimum. Stage 1 will be for downloading the dependency. Stage 2 will be responsible for building the application. And stage 3 will be for running the application. Let's start with stage 1. In this stage, we are going to download the Maven dependencies. First, we need a base image. I want to use an image that has JDK 21. So, I'll start with from Eclipse Tumarine 21 JDK Alpine. I am using Eclipse Tumarine because it's the Eclipse distribution of OpenJDK. The 21 JDK, this part means we are using JDK version 21, and the Alpine tag means it's built on Alpine Linux. Alpine is very lightweight, so our final Docker image will be small and will download much faster. As mentioned, this stage is responsible for downloading all the project dependencies using Maven. These dependencies will be cached and reused in stage 2, so they don't need to be downloaded again. Now, I'll give this image a reference name. I'll call it dependencies. Next, I need to install Maven. I'll run the command apk. Here, this apk is the package manager for Alpine Linux. Then add -- no cache. The no cache, this option prevent apk from storing temporary files. This keeps the Docker image size smaller. And then the package name Maven. After that, I'll create a working directory inside the container. Using the work dir instruction, I'll name this directory build. Here, if this directory does not exist in the container, Docker will create it. And it will also set this build as the current working directory. Next, I'll copy the pom.xml file into this build directory. It's important to note that we'll copy only the pom.xml file, not the entire project, because at this stage, we are only downloading dependencies, not building the application. Now, Maven will read the pom.xml file and download all the required dependencies. Finally, we run the command mpn dependency :go-offline. This tells Maven to download every dependency the project needs and store them in the local Maven cache inside the container. This will make our build faster in the next stage. After downloading the dependencies, let's move to stage 2 where we'll build the application. In this stage, we'll reuse everything from stage 1. Instead of starting with brand new image, we start from these dependencies and call this stage builder. This way, we already have Maven installed and all dependency downloaded. In this stage, we need to copy the source code into the container. So copy the src directory into the current working directory, which is build. Then we run the Maven command to build the application. mvn clean package, then -d. I would like to skip the test. This builds the application and skip the test. Once the build is complete, we move to stage 3. Stage 3 is responsible for running the application. Here, we'll create a small runtime image that contains only what we need to run the application. Again, we'll use Eclipse Tumarin, but this time instead of JDK, we'll use JRE. Because to run application, we only need the JRE, not the full JDK. We'll call this stage runtime. In this stage, we set the different working directory called app. Next, we'll copy the jar file generated in stage 2 in this builder stage into this app directory. Use copy instruction. I'll copy this from builder stage. So here provide -- from and this equals builder, the name of the stage. The jar file is generated inside the target folder inside build directory. So here we need to provide builder / then target. Next, I'll use a wildcard followed by .jar. I am using this wildcard to match whatever jar file was generated by Maven in this builder stage, and let's copy it as app.jar. Now, let's define how the application should run. Usually, when we run Spring Boot, normally we type this command in the terminal, java, then -jar, and then the name of the jar file. In our case, it is app.jar. But in a Docker file, we cannot provide the command in this plain string form. Docker expects command as array, where each part becomes a separate elements. So we need to split the same command into separate elements. Here, Java is one element, then this jar is another, and app.jar is another element. Finally, to instruct Docker to execute this command when the container starts, we need to provide it as an entry point. Now, let's build a Docker image. Open the terminal. To build a Docker image, we need the build command. Docker build. Then provide -t for tagging. I want to tag it as rest-crud. Then dot. With that, this command will search for Dockerfile in the current directory and build the image. Our image is building. Here, there is an error. Failed to build. Okay. No such file or directory. Let's check. Here is the error. It is saying that it could not find the file. Let's check the Docker file. Here we have this file path of the jar file, builder /target. Docker is saying this builder directory does not exist. Let's check. In stage 1, we name this as build, not builder. Okay, let's fix it. Again, open the terminal and run the previous command. This time, the image built successfully. Let's check available images now. To get the images, the command is docker image ls. Here you see the list of image. This is the image that we have just built. But this image version is set to latest. And I do not want this. I want to provide a specific version. So let's remove this image and build it again. To remove this, let's run the command docker image rm and then provide the image name with version. See, the image is deleted. Let's check the list of images again. So our REST card image is not listed. Now build the image again, docker build -t rest-card, then provide colon and the version number 1.0. So this time the image built successfully. Let's check the list of images again. Here we have this REST card image with version 1. Now let's run this. To run, docker run, then -p. I will map host port 8080 with port 8080 of the Docker container. I will name this container rest_card_container. Then provide the name of the image to run. See, our Spring application is starting. Here, it seems there is a problem. Let's check what it is. Here, it's saying it's unable to connect with the MySQL database. Okay, let's open the application.yml file. Here in the database URL, I have provided localhost. This localhost means own machine. In Docker, each container is treated as an individual machine. So, our application running inside Docker container is searching for the database inside that container, which is not present. That's why it's unable to connect. In fact, I am running the MySQL database in Docker in a separate container. The application needs to connect with that. Let me show you. If we run the command docker ps, here you can see this MySQL container. Now, to connect with this MySQL container from another Docker container, in our case, our REST card container, we need to use bridge network. With that network, the container will be able to communicate with each other. Let me open Docker desktop. Here you see we have this list of container. This is our REST card container that is unable to start. Let's delete this. Back to the terminal. Let's stop this MySQL container for now. Docker stop MySQL container. Now I'll create a network inside Docker and connect MySQL container with that network. To create a network, the command is docker network create. Let's say the name of the network is app-net. So the network is created. Let's check the list of networks. Here you see the app-net network is created and this is a bridge network. Now I'll connect the MySQL container to this network. Docker network connect, then the network name app-net and the container name MySQL container. Now let's inspect the network to see if MySQL container is connected. It's not showing here. Let's start MySQL container. Now inspect the app-net again. Here in this container section, this is MySQL container. Great. Now we'll run our REST card image and instruct it to connect with MySQL via the app-net network. Docker run. Here we can connect with the app-net network using --network. Then provide the name app-net. Now I'll define the environment variable -e. First one is dbhost. This is the environment variable that we set for our database URL. Here, instead of localhost, we need to provide the container name. Another environment variable is dbschema and it is productdb. Next environment variable dbuser. Set it to root and after that -e and it is for password. Now we need to map the port using -p, map host port 8080 to container port 8080. I will name this container rest underscore cart underscore container and run it from this image rest cart 1.0 and press enter. Here, this time, our application inside the Docker container runs successfully. This time, it's running on port 8080. Let's check using Postman. Here was the request to get the product. Let's send the request. See, we're getting the list of products. Cool. So far, we have only Dockerized the Spring Boot application itself. That works fine on our machine because we already have MySQL installed, or specifically running MySQL on my Docker. But now, imagine sharing this project to another developer or deploying it on a fresh server. If MySQL is not already installed there, the application won't even start. Someone has to install MySQL, create the database, configure users, and make sure the port is open. That's extra setup and extra chances for things to go wrong. To make life easier, we should not expect the environment to have MySQL pre-installed. Instead, we can package the database along with the application, and that's where Docker Compose comes in. With Docker Compose, we can run the Spring Boot app and MySQL together as a single setup. One command, everything starts. The app and the database talk each other automatically. In the next video, we'll use Docker Compose to run both the application and MySQL together, so anyone can clone the project and start it without installing anything locally. See you in the next. Bye bye.